Hey everybody, this is Ty from K2 Data Science and Engineering. In this video series, we'll walk through building a Twitter filter using Python. As always, let's tackle this through a business context. In this project, you are working for a marketing agency. They want to examine customer feedback for direct-to-consumer startups, companies like Warby Parker or Allbirds. You decide to build a streaming pipeline that downloads tweets, filters them based on certain brands, and calculates a sentiment score to see how people are feeling. In order to do this, we will need two separate services. On the left side, we will have our Twitter streaming service. This will be constantly running 24/7. It will be connected to the Twitter streaming API and push the tweets to our storage solution. On the right side, we will have our web dashboard. This too will be constantly running 24/7. It will query our storage solution routinely to get the latest tweets. Setting up the two services will be straightforward. So the data engineering question, if you will, is how should we store the data? Obviously, we could store the tweets in a database like MySQL and have the web app read them from there. But given the small schema, we're only going to store tweets, not users or any other relational data, and the transient nature of the web app, at any given time, we really only care about the top 20 most recent tweets. This seems like overkill and leads to an unnecessarily write-heavy application. Instead, one of the various in-memory key value stores seems like a much better fit. Each has their own pros and cons. In this case, Redis is perfect. It has first-class support for basic data structures such as sets and lists. This means that instead of reading and writing entire lists of tweets, we can append a single tweet at a time, and we can efficiently retrieve the exact number of tweets that we need on the web app side. For example, we can just extract 20 for a full page view and intervals of 5 when we do AJAX requests. Redis is also stable, highly performant, and has a solid, extremely easy-to-use Python library. It supports basic persistence, although we won't be using that for this app. Let's walk through the entire data pipeline. We'll start off by using Twitter Streaming API. This provides developers with a very efficient way to tap into the public Twitter stream. All you need to do is open and maintain a single HTTP connection, passing in a few filter parameters. Twitter then keeps streaming matching tweets to you. We have the option of either sampling the entire public stream or passing in a list of keywords or user IDs to track. The Python Tweepy package allows us to easily connect to the API without worrying about too many of the internal configuration options. Each tweet has hundreds of fields, so we'll use Python to extract the relevant fields and TextBlob to generate a sentiment score. Each tweet will then be represented as a dictionary and stored in Redis via its list data structure. When we want to extract tweets for our dashboard, we'll want to format the data. This entails making links clickable and highlighting the brand mentions. Last but not least, we'll show the last 15 tweets that matched on our web dashboard using Flask in conjunction with HTML and CSS. Here is the final dashboard. It's nothing really intense. We just used Twitter's Bootstrap CSS framework and displayed the most recent tweets. We're monitoring this company, so mentions for the brands Warby Parker, Bonobos, Casper, Glossier, Dollar Shave Club, and Allbirds. So you can see here we have the tweet text, then we have a link to the tweet or an external link, and then the profile photo, and then the username. And if you go to the bottom, there's a refresh button you can access, and you'll also notice the coloring of the tweets. So here you can see they're green, and that indicates positive sentiment. If there's no coloring, if it's just gray, that indicates a neutral sentiment. And then if it is red, it's a negative sentiment. That does it for the introduction video. In the next video, we'll start working with Twitter's streaming API and downloading the tweets with Python.